Welcome to the deep dive. If you are following the world of large language models at the start of 2025, you're probably still asking that same old question. Is it just mimicking or is it actually thinking?
Yeah, that was the big debate.
Well, by the end of the year, that question was pretty much settled. 2025 was the year we stopped just talking about AI reasoning and, well, we saw it emerge as a tangible, scalable technology, and frankly, it was shocking.
It really wasn't a gradual thing, not at all. It was a fundamental architectural shift.
Right.
Suddenly, these reasoning capabilities, which we all thought were years away, became a core feature that companies could, predictably optimize for.
Exactly. And we have a massive stack of sources in front of us. Lab reports, technical breakdowns, critiques, safety analyses. Our mission today is to give you the shortcut to understanding the huge paradigm changes of 2025.
Hmm.
We're going to dive into the technical breakthroughs that unlocked it all, explore how we've had to completely rethink what AI intelligence actually is, and then tackle the urgent and often contradictory state of AI safety.
And what really stands out when you look at all this is this central tension. One researcher put it perfectly. He said these LLMs are a lot smarter than I expected and a lot dumber than I expected.
Right.
They can solve a problem a PhD would struggle with, but then get tripped up by grade school logic. But the consensus is clear. The field is wide open. We're nowhere near even 10% of the potential that's just been unlocked.
Okay, so let's unpack that. Let's start with the technical engine that drove this whole thing. Reinforcement learning from verifiable rewards.
Right, but first we need to set the scene. For the longest time, the recipe for building a powerful LLM was very stable. It had three proven steps.
The old stack.
The old stack. First, pre-training on mountains of data. Second, supervised fine-tuning SFT with high-quality examples. And third, that very short stage of reinforcement learning from human feedback, RLHF.
Which was basically just to make it polite and helpful.
Exactly. But then 2025 brought in what is now the de facto new stage, the one that broke the mold, RLVR, reinforcement learning from verifiable rewards. This is the thing that gave us scalable thinking.
So what's the core difference?
It's all in the reward function. RLHF asks a model to optimize against, messy human preferences. It's like grading an essay on how nice it sounds.
Subjective.
Totally objective. RLVR just ditches that entirely. It optimizes the model against objective, non-gameable reward functions.
So instead of being judged on politeness, it's judged on results, like complex coding challenges or math proofs where the answer is just definitively right or wrong.
Precisely. The outcome is binary. It's verifiable. And this is crucial. RLVR involves training for a much longer period than that thin RLHF stage. You're not just polishing the surface anymore. You're fundamentally changing the gears inside.
You're letting it chew on thousands of these hard problems.
Hundreds of thousands. And what happened?
What did happen?
This is where it gets really interesting. The LLMs, under this intense objective pressure, spontaneously developed these complex, human-like strategies that look exactly like reasoning.
Like what? What kind of strategies?
They learn how to break down a problem into intermediate steps. They learn to backtrack when they hit a dead end, and they learn really complex self-correction.
Well, how could they prove that? I mean, how did they know it was learning a strategy and not just getting better at pattern matching?
The DeepSeek R1 paper had some great examples. They could actually trace the model's internal steps and see it adopting these methodologies. Like, it would realize a direct calculation failed and then recursively try a different approach.
Wow.
It was proof of internalized strategy, and the inflection point for all of us was, I think, the OpenAI O3 release in early 2025.